is how motion is biased in one direction. The three is easier to understand when it is treated as a flow model, where states are connected by pathways, and the main question is how motion is biased in one direction. The three-layer architecture can be read as an outer stage that creates directed flow, a middle stage that filters that flow, and an inner stage that combines and resets the remaining state. The explanation begins with the basic Markov idea behind the moving streams, then follows the flow through the compression layer, the filtering layer, and the core layer. A Markov chain is a model in which a system moves from one state to another by transition rules, and the next state depends on the current state rather than on the full history of how the system arrived there. In this schematic, the channels of the pump can be treated as Markov states, while the allowed moves between channels form a network of transitions. Detailed balance is the condition where every forward transition is matched by an equal reverse transition, so there is no lasting net current around the network. A pump requires broken detailed balance, because the forward transitions must be stronger than the reverse transitions if probability is going to circulate instead of simply canceling out. The outer layer represents this break in balance by using 3 trefoil-style loops, each one acting like a chiral path, meaning a path with a handed direction that is not the same as its mirror image. As the 3 loop families send phase streams through the network, the reverse pathways are described as suppressed, so the combined current is positive and directed inward rather than neutral. This outer stage is therefore the compression stage of the schematic because it gathers separate circulating streams and biases them toward the core. Directed network flow is the movement of some quantity along connections that have preferred directions, and here the quantity is probability current moving through the channel architecture. The middle layer is shown as a set of square lens-like grids, and its role is not to create the original bias, but to restrict the incoming flow to patterns that fit the allowed grid rules. This kind of filtering can be described as a projector, which means a rule that keeps the parts of a state that match a chosen pattern and removes or redirects the parts that do not. The pandiagonal structure means that rows, columns, and wrapped diagonals are treated with a repeating symmetry, so the middle layer acts like a geometric sieve for the directed current. After this filtering, the flow reaching the center is no longer just raw circulation from the trefoil paths, but a more organized set of modes shaped by the grid constraints. The inner layer uses symmetry in a different way, because it combines positive and negative families of streams into a core structure that is described by paired 12-part rings. Symmetry in a geometric model means that certain transformations, such as rotation or reflection, preserve the structure even when the flow moving through that structure has a preferred direction. The schematic then maps the combined 24 stream positions into a 7-point pattern, and the mismatch between 24 positions and 7 points creates an asymmetric wrap rather than an even division. That asymmetry is interpreted in the model as a torsional twist, meaning a twist caused by the way the circulating paths are forced to merge into a smaller rotational pattern. The final core step is a logging or accumulation disk, where the remaining organized contribution is added to a stored scalar value, which is a single number measure of the accumulated state. The reset stage returns the leftover rotational phase to an identity state, meaning a neutral starting orientation for the next cycle of the pump. Read as a clean 3-layer schematic. The system works as a directed Markov pump, in which the outer trefoil layer breaks balance and pushes current inward. The middle pandiagonal layer filters the current into allowed modes, and the inner core merges, stores, and resets the flow for another cycle.